The first thing anyone can do about any issue is get informed. First, let's review what the USGA's 2020 Course Rating System Manual says regarding measuring golf courses, Section 6, 2, Approved Methods of Measuring Golf Courses, page 17. Notice the USGA CRS Manual says the EMD method must be accurate to within 6 inches for up to 250 yards when used. Is your laser rangefinder that accurate? Regarding the GPS system, the USGA manual states, this method can be used to measure golf courses if the Global Positioning System, GPS, is accurate to within 6 inches for up to 250 yards. One could say striking the ball onto the green every time is accuracy, but striking the ball within inches of or into the hole is precision. The Mesa 2 system is accurate to within 6 inches for up to 250 yards of length because it's precise survey grade equipment. Today we'll explore measuring golf courses via satellite and how the measuring system works. How does GAM measure courses via satellite? Once the raw data is collected, what do we do with it? How is this data transferred to GAM's measurement form? What data populates GAM's measurement form? We'll review the field information that can be entered into Mesa 2's notes. The GNSS satellites emit signals in milliseconds 24/7 to the fixed ground base stations. The satellites work in unison to triangulate distances of length and elevation. The Mesa 2 is also receiving these millisecond satellite signals while collecting raw data points on the course. The satellites are also simultaneously triangulating the measurer's exact location. While later post-processing the raw field data, the Mesa 2 software uses the fixed MDOT base stations to further triangulate the measurer's exact positions during the data collection. This post-process triangulation gives GAM the very precise length and elevation points required by the USGA. How does GAM measure courses via satellite? The measurer still follows all the current USGA criteria according to the USGA CRS manual to measure golf courses. We still locate marker tee placements by pad. We divide the pad by the number of tees, finding the marker's midpoint as required to establish true marker locations. We still gather all of the essential data currently collected. Once the raw data is collected, what do we do with it? The Mesa 2 raw data file is sent from the field to GAM's computer. The raw field data is post-processed to populate GAM's measurement form. How is this data transferred to GAM's measurement form? The Mesa 2 field data is gathered in latitude, longitude, and elevation height format. This raw field data is then post-processed using the fixed MDOT stations. Once post-processed, the final data populates the GAM measurement form. Let's review the final data that populates GAM's measurement form. The next few slides should look familiar because they still gather the required data transferred to GAM's Form 1s. They will also highlight some of the added data points a captain can utilize to assist raters with completing their rating tasks. The Mesa 2 now includes the tiered green and over the green categories. Certain data is not a defined point by the satellite and can only be recorded in the notes. Here are some examples. A fraction of the green must be paced to ascertain the greenside bunker rating. Laterals can be lasered from green center to save walking out to each location. A tiered green should be determined by observation. The green surface ratio can only be determined by the amount of ball roll downhill and uphill. The green speed or stimp must be determined via the stimp meter. The rough height must be physically measured by a ruler and the masthead information entered accordingly. The post-process measuring sheet to the right provides all the pertinent information GAM requires in a condensed structure to complete our Form 1s from all T-marker positions and for all genders. We hope you've enjoyed this brief overview regarding an alternate modern method to accurately and precisely measure a golf course by means of the GPS system of data gathering.